Hello everyone, welcome to this lecture on the Lex utility. So we are going to look at a Linux utility called the Lex, which is used for implementing lexical analyzers. So let us see what this Lex utility is all about. So the Lex utility, it is a Linux utility that we use in order to identify tokens in a given program. So if I give as input a program, this uh, this utility, that is this Lex, will help us to find out the tokens for that particular language, provided we give the specifications for the tokens. So you have to use this in the Linux platform. And to recognize the different strings of characters that matches certain patterns, okay, that is how we are going to identify the tokens. We are going to have certain patterns, and we are going to match that with the input strings of characters. And if there is a match, we will say that this is a particular token. So the Lex utility will help us to do this. And how we have already seen that we can specify the patterns through our regular expressions. So we can represent the patterns or the tokens through regular expressions, and this Lex utility will help us generate a program which will take as input the source program, and it will give as output the tokens of the language. So let's see how it works. So first of all, Lex is not the actual program which will take as input the source program and give the tokens as output. Instead, it is a program generator. That means it will take we will have to write the specifications in one program, in one file. So we write the specifications in one file. The specifications of the patterns we write in one file. This we give to the lexical analyzer utility. And this utility will convert these specifications into a C program. So the actual program which is going to do this lexical analysis is not this or this, but it is the output of this of the Lex, that is the C program which is going to do this. So what the Lex will do is that it will generate a scanner in C from a set of specifications provided by the programmer. So we will write our specifications in this particular file. Then we will run it through the Lex utility, and we will get a C program. So this C program is our lexical analyzer. This is the lexical analyzer. Okay. So what the C program will take as input is that it will take as input the source language program, and it will output the sequence of tokens. So if we can see here, so first I have my Lex program written. It will be of the format. I can write it as lex.lex. You can use the extension .lex, or you can sometimes some implementations they use .l. So first is the name of my program where I have written the specifications, that is in first.lex we have written our regular expressions for identifying the tokens of that specific language. So this is our Lex program. Next, what we do is we run the Lex utility on this Lex program. Okay? And then what we get is the lexical analyzer code. And this is kept in a file called lex.yy.c. By default, it goes to a file called lex.yy.c. Now, because this is a Lex is a Unix utility, you can redirect the output to any other program file, any file with the extension .c. Okay, so but if you don't give any option, then it will take the form lex.yy.c. Now with this lexical analyzer code, what we will do, we will have to, this is a C program, okay? So this C program will have to run it through a C compiler. And the output that you get is your executable lexical analyzer program. So I hope this is clear. First we write the specifications. We will write the specifications here, run it through Lex, we get a C program. This C program we compile and we get the executable program. And to this executable program, I give as input the source program which I am trying to compile, and I will get as output the tokens as per this source program. So in this way, we can use the Lex utility to generate the lexical analyzer. That is what is important from the compiler point of view. We need the lexical analyzer, and this is how we are going to create. Now, let's see how we can write a lexical Lex specifications, because that's the first step. If you go back here, you can see the first step is writing this program, first.lex or first.l. So how do we write that? So we have to write, as I have mentioned, that we have to write this specifications with the help of regular expressions. So we are going to use regular expressions for doing this. Now, the regular expressions that are used for Lex, you'll find that it is slightly different as compared to the ones that we have used for writing regular expressions in, say, your TOC course or in the previous videos that we have seen. So this we will see how these extended regular expressions are written. But before that, the Lex specifications consist of 3 different sections. You have to write the code in 3 different sections. The first section is the definitions section. So here you can include your header files. You can write your include statements. Okay, you can define your macros. This is just because this is going to be, ultimately it is going to be a C program only. So you have your include statements, you have your macros, and then if there are any global variables, if there are any variables that you'd like to use, then this is the place to define it under the definitions. Okay. Then comes these 2 symbols, 2% symbols. This indicates that definitions section has come to an end. This is followed by the rules section. So the rules are the main, you can say the central part of this Lex specifications, because this is where we specify the regular expressions and the actions that will be taken if that regular expression finds a match in the input. So you have the rules, followed by again the 2% symbols, which marks the end of this section. And finally, you have some user routines. So user routines would usually be some routines that you are going to write, some functions that you are going to write. So functions in C. Okay. So you will find that most of it, this section will be all C. Here you will have something of C and something of regular expressions. We will just see in a while. So now this part, that is the rules, this is mandatory. You have to give the rules. The definition and the user routines are optional. Even if you omit it, no problem. But remember, these percentage symbols are always mandatory. You have to keep these. And the rules, at least one rule you have to keep. So this is the basic format of a Lex specifications: definition section, rules section, and user routines. So let's see how we will write the rules. We will look at the optional sections later. So how will we write the rules? So usually a rule consists of, again, 2 sections. So I should not say sections, let me say 2 columns. Okay, first of all, we have the pattern, which is represented by a regular expression. But here, let me add modified, or extended, modified or extended regular expressions. Then this is followed by the action section, action part. So you have patterns and action. All right. So what is the action? The action, it is represented by a C program fragment. So again, in the action part also, you have C program segments, which would indicate what action is to be taken by a program if a match to the pattern is found in the next input. So we write it something like this. So the pattern we write here. We write the pattern here, and here comes the action. So this is your rule section. So you have to write it like this. So here comes the pattern. Your pattern is here, and your action is here. So this action is nothing but C program segments. So if the input matches this pattern, then the code which is here will get executed. Okay, so this is how we write the rules. Now let us look at the regular expression that is used in case of Lex. So as I said, it is not the same format, even though it is very, very similar, but there are some extensions. So a Lex regular expression is a word made up of text characters, like the letters of the alphabets, digits, and so on. So if, say, your language is C, then the character set of C, is the alphabet of the language, and then any combination of these characters, of the characters in the character set, will be valid here. They will represent the text characters. The second one that it will contain are operators. So these are certain operators. You can see quotes, slash, opening curly brace, closing curly brace, then square bracket, then the caret symbol, dollar, less than, greater than, question mark, dot, star, plus, then or, then parenthesis, another slash. So all these are operators, and they have special meaning. Like you are already familiar with regular expressions, we know that star indicates 0 or more repetitions, right? And also we have seen this means or union. So if I write A or B, it means either A or the string B. So like this, each of these has certain specific purpose in the regular expression of length. Now you might wonder that see all these, the star, plus, or, bracket, curly bracket, these are also a part of the C character set, isn't it? This curly bracket, this is also a part of the C character set. This less than, greater than, plus, minus, dot, all these are elements of the character set. They are all here. So will these fall under this category, or how will the regular expression identify that it is not the character but the operator? Okay, so they will have two meanings. It can represent a character, or it can also represent an operator. So sometimes these special symbols or these operators can also appear in the text. In that case, if you can recall, in a regular expression, we have something called escape sequence. Okay, so we can use this escape sequence, and the escape sequence is slash. So if I want star to mean operator, I will just give, say, A star. So it means star here is an operator. here it is an operator. Star is an operator. But if I write A slash star, all right, now here slash star is preceded by the escape character slash. So star here means the character star. It means the character star. Here it means the operator star. Okay, so escape sequence is important. All right, now that's what it's written here. An operator can be used as a text character if it is preceded with the escape operator, which is backslash. Okay, so let's see some forms, different forms of these operators and what they mean. So in the simplest form, we see that only character strings, the simplest form of regular expression in Lex, consists of character strings without operators. So if I say my characters in the C character set are A to Z, small a to Z, capital A to Z, okay, 0 to 1. Okay, so all these, if I say red, blue, green, all these are nothing but strings of these characters. So this is how we can represent, in the simplest form we can represent a regular expression. So I have a same, I think this is the same thing I had given. So red, blue, green, these are nothing but regular expressions of the sequence of characters. Now, if anywhere in your source program there is the word, say, red, then it will find a match here. If there is the word blue in small letters, it will find a match here. If it is the word green is there in your input, then it will find a match here. So it matches any occurrence of those character strings in an input text. And a very good example of this is in your keywords of a language. Keywords. Okay. So if I say if, else, then, all these are keywords. So you can match it directly with this pattern. So this is the simplest form. Then let's say using operators. Let's see how we can use operators. So you can form regular expressions which will be using the operators, and then all strings that matches this regular expression will belong to a certain class. Some examples, like say plus. Plus, what it means, plus operator means one or more occurrence of the preceding expression. Say, before I go ahead, let's see one example. Plus means, if I say A plus, it means one or more occurrences. So I'll get A, I'll get AA, I'll get AAA, and so on. One or more. Question mark means 0 or 1. So if I say A question mark, it may mean the empty string epsilon, or it may mean A. It does not mean any more repetitions. Star, of course, it has the same meaning. A star would mean 0 or more repetitions. So epsilon, if it is 0, empty string, 1 repetition, 2 repetition, 3 repetitions, and so on. Then I have, okay, this is just the examples which I have just shown out here. A star matches empty string and A, and A question mark, and A matches all of these. Then some more operators. Or, this again you know, or means either A or B. This is different here. You can see here, parenthesis. So parenthesis, not parenthesis, this curly braces. So curly braces, it means repetition from one time. If it is say like this, A 1 3. Okay, that means the character A is to be repeated 1 time, 2 time, and 3 times, up to 3 repetitions. So it matches 1 time repetition A, 2 times repetitions AA, 3 times repetition AAA. It doesn't mean anything more than this. So this is the entire thing represented by this regular expression. Okay, so repetition that matches 1 to 3 repetitions of A. So if I get the string A, it will match with this. If I get the string AA, then it will match. If I get AAA, then it will match. But if I get AAAA 4 times A, this will not match. This will not be a match. No match. So that is the curly braces. Then parenthesis is mainly for grouping. Okay, so you can see here. It is written A within parenthesis is B1 to 3. That means it matches. That means it must first start with A, followed by either 1 times B or 2 times B or 3 times. So the parenthesis here is used to group together this operations. Then we have square bracket. So square bracket can be used to represent any characters within the given set of characters. Like say for example again, look at this example, A, E, I, O, U. A, E, I, O, U. So if there is a match to this, for this regular expression, A will match, E will match, I will match, O will match, and U will match. So anyone that is represented here. You could have written it like this: A or E or I or O or U. You could have written it in this manner also. It is equivalent. Okay, so that is the square bracket. And one thing to remember is that when you write it like this, there should not be any space in between, because it will consider space to be one character otherwise. All right, the next one. Let me just clear this up. Okay, so the caret symbol. The caret symbol here, it means all except the characters specified after it. So if you can see this example, caret of ABC, and then this is included inside the square bracket. It means all characters other than A, B, or C. So not A, not B, not C. And it does, ABC doesn't have to come together. It can be, because this means any one of these two, these three, and this means none of these three. Okay, but if I write A, B, C caret without the square bracket, it means not A. So it can be any character here other than A, but ending must be C. So it can be B, it can be C, it can be D, it can be any character, but not A. Okay, so you can notice the difference between this and this, because the parenthesis or the square brackets here, they represent this class of characters. Okay, so minus. Okay, here again let me clear this up. So another symbol is here minus, dash, not minus, dash. So this is used with the square bracket. So I can write something like this: square bracket with a dash between. So this is used for representing a range of values. So if I give small a to small z, it means all characters from small a to small z. Similarly, I can write capital A to capital Z. So this means all characters from capital A to capital Z. Similarly for digits also, 0 to 9. So this can be used only when there is an ordering among your characters. So A, B, C, D, capital A, capital B, all these there is an ordering. So you can use this range. But if suppose I want let's say I want question mark, colon, semicolon. Okay. Now there is no range here, so I cannot specify these using range. I have to use them individually. So let's look at some examples. See the first one. It says A to Z, A to Z. That means the first character can be either a capital letter from A to Z or a capital or small letter from A to Z. So all letters starting with capital A up to capital Z or small a up to small z. These are allowed. Okay. Followed by, so this whole thing represents one character only. Okay. Now this second part, you can see this is also a range. This is also using the character set, that is the square brackets. So and it is also representing range. So you can see A to Z, capital A to Z, small a to Z, 0 to 9. Okay. So that means after this I can have either a character small a or capital A or 0 to 9. Okay. But how many times this is to be repeated? This is to be repeated 0 or more times. So our minimum length of the strings generated by this language is the minimum length, because that is coming from this camp. It must, that means it must start with a either a small letter or a capital letter, and it can be followed by 0 or more repetitions of letters and digits. So if I say A P P L E, okay, this satisfies this because it starts with a small letter followed by multiple small letters. Simply if I write A, capital A, this is also valid because first one it satisfies, the second one is 0 times repetition. If I write A 29, this is also valid because it starts with a letter and it is followed by multiple digits. Okay, so all these are valid answers to this. For the second one, for the second expression, you can see it says A or B, A or A B slash C D plus. Okay, now this is there is a grouping, question mark E F star. So it means, first look at this group. Let me use this group. Okay. So in this group, what I have this or this. All right. So it can either be AB. Okay, it can be either AB or C followed by D is plus times. So D at least one. So I have AB followed by or starts with AB or CD. Okay. Repeated how many times? Now I have the question mark here. So this means 0 or 1. So this can be repeated 0 times. So if this is repeated 0 times, I have epsilon here. That means from here, from this part, I am getting a string, empty string. Okay, I have decided not to use this, follow the 0. Okay, and if I choose to follow 1, that means this whole thing will be repeated once. So if this is repeated once, then I have either AB or CD. Or if I have CD, CD is CD plus, so I can have CD, that is 1 or more times, so CDD or CDDD, you can go on. Okay, so you can see this is coming from CD plus and this is coming from your E. So either this or this. Okay, and again this will be, whole thing will be repeated 0 times or 1 time. Okay, then let's look at the next part. The next part is this. So EF star. So EF star would be repeat EF either 0 times or more. So 0 or n. So n can be 1, 2, 3, 4. So if it is repeated 0 times, then if this is repeated 0 times, then it will come with epsilon. So I will get epsilon as a string. If this is repeated with if this gives me epsilon, so I will get AB as a string, or I will get CD as a string, or I will get CDD as a string. So it will go on like this. But if I choose to repeat this more than 0 times, that is at least once, then I will get EF is a valid string, because from here I am taking epsilon. Okay, from here I am taking epsilon, or EF with AP, so AB EF, or CD EF, or CDD EF. It can go on like this, and I can just continue. This is repeated only 1 time. I can repeat 2 times. I can repeat 3 times. So the process will continue. So basically, if I have to spell it out, then I will say that it is a string. It is this regular set represents a string, a set of strings which either starts with AB or CD with D repeated, where D can be repeated more than 1 time, at least with CD. And it can be followed by EF, repetitions of EF multiple times. So this is your regular expression for the second. Let me again just clear this so that we can write the next one. So for the next expression, this is, so you can have this slash star. Okay, then 1 to 9 star. So slash star. So backslash, if you recall, this is the escape sequence. Okay, so when the escape sequence appears alone, that means it is appearing in front of a operator, which is occurring as a character, and it is not occurring as an operator. So it is not occurring as an operator. It is star is occurring as a character. So I will get my string would be starting with star, followed by 1 to 9, again 0 or more times. So 0 times, then only star. If it is 1 time, say 1, 2, or star 2, or star 3, okay, up to star 9. If it is repeating 2 times, so star 1, 2, star 1, 1, star 1, 3, and it will go on 2 times, 3 times. It can continue in this manner. So it is single digit or more, single or more digit, or 0 or more digits of from 1 to 9, starting with a star. Then this one here. Now one way of putting this quotes, I did not talk about this quotes operator. This quotes represents whatever you have given inside this quotes as a pattern. So if I say string ABC, quotes within quotes ABC, it matches the pattern. Any string ABC matches the pattern. Okay, so exact match. So here in this example, Y slash quote Z. Okay. So here, what is this going to match? This is going to match Y quote Z. It's going to match Y quote Z. Why? Because this is what? This is the escape sequence. So quotes here does not appear as an operator, it appears as a character. And finally, the last one here, Y double slash Z. So here, Y is of course Y itself, Z is Z itself, and in between I have 2 backslashes. So that means one is an escape sequence and the other is a character. So Y slash Z. This is what this regular expression matches. So you can have a look at this list of operators and what it means. Okay, all these are described out here. So you can read through this. I have also put it as a PDF, so you can go through this. So this is about specification of regular expressions. In the next class, we will look at the specifications of the actions, how we can write the actions.